All right, this video is to go over some mole comparisons. This shouldn't be too difficult for you to do, but let's try it. Which of the following is the larger quantity? 2.5 moles of niobium or 5.5 moles of tungsten? Well, these are already in moles, so we know that 5.5 is larger than 2.5, so we can just put a little check mark right by that. Our 5.5 moles has to be larger than 2.5 moles of niobium. All right, next one. 55.3 grams of lead or 33.9 grams of lithium. They might be tempted to think it's the lead already because there's more grams, but remember we must make all comparisons by converting the moles. So we're going to convert both of these to moles to make that comparison. So I've got 55.3 grams of lead. This will be a one step because it's got the word mole in it. So I'll times that by 1 mole of lead divided by 207.2 grams of lead. Now the 207.2 is the atomic mass of lead, okay, from the periodic table. So I'll take 55.3 divided by 207.2, and that's 0.267 moles. 267 moles of lead. Now we need to likewise with our lithium, so I've got 33.9 grams of lithium. We know this will be again a one-stepper since the word mole is in the name of the question. So we need to get that to moles of lithium. And we'll times this by 1 mole of lithium over its atomic mass of 6.94 grams. And again, that comes from the periodic table. So I'll take 33.9 divided by 6.94 and get 4.88. So the larger quantity is going to be the larger moles, so that's going to be lithium. So let's put a check by that. 4.88 moles is definitely greater than 0.6267 moles. Okay, so we're going to try one more. All right, so let's take a look at that next question. What is the mole ratio between 14.5 grams of sodium and 10.1 grams of sulfur? Okay, well, let's take a look at this. We're going to convert both of them to moles again because that's what they want you to do in order to do a mole ratio. So we'll take 14.5 grams of sodium, okay, and we're going to convert that to moles. Notice I'll have 1 mole of sodium on top again. I'm going to divide that by the atomic mass of 22.99 grams of sodium. Again, we get that from the periodic table. So 14.5 divided by 22.99, that is 0.631, we'll call it 0.631 moles of sodium. All right, let's do likewise and convert our grams of sulfur into moles. So I have 10.1 grams of sulfur. And again, we know this will be a one-stepper because there were moles in the question, of course. And we need to convert that to moles of sulfur. So I'll times that by 1 mole of sulfur by 32.06 grams of sulfur. Again, that's coming from the periodic table. So let's take 10.1 and divide it by 32.06. That is 0.315 moles. 0.315 moles of sulfur. Now, next part says determine this empirical formula. Well, we got to do a mole ratio. So I'm going to take the moles of sodium and divide it by the moles of sulfur. So that's 0.631 divided by 0.315. So 0.631 divided by 0.315, and that's 2.00 or 2. And what this means is we have 2 moles of sodium for every 1 mole of sulfur. So that means we have Na 2S for its empirical formula. We have twice the amount of sodium for every 1 sulfur, so that means Na2S. Now, if we were to compare this formula that we just derived, we can do it by crisscrossing charges. Sodium is in group 1, which is a +1. Sulfur is a group 16 element, which is a -2. When we crisscross our charges, we end up with a 2 here, and of course a 1, we don't write 1s. So by crisscrossing the charge method, the formula for sodium sulfide is Na2S. Okay, and that shows how we can convert grams into moles and what we can use them for. Okay, that is it for this lesson.